Ibel Nwafu. Dr. Nwafu is a professor at Villanova University in Philadelphia. So he is a computer scientist, a data scientist, so he will lead the discussion for today's module, that is data preparation, exploration, and visualization. So without any further ado, Dr. Nwafu, it's all yours.
Good morning. Can you all hear me? Good. John, can you hear me?
Yes, I can hear you.
Okay, all right,
yes.
Sounds good, awesome. All right,
can you all hear? If you are here and you can hear us loud and clear, why don't you turn your camera on and wave your right hand?
Okay, seems
so
like
we know you are here, you can hear us.
Okay, yeah, okay. Seems like the general consensus is we can all hear. Awesome. Good morning, everyone. Yeah, good morning. Thank you so much, John, for the warm introduction. Hello, everyone. My name is Ibel Chukwunwafor, Dr. Nwafor, Ibel, whichever you prefer. I am an assistant professor at Villanova University, where I teach computer science and also do data science research. So that's a little about myself. And today, or the next 2 days, today and tomorrow, we are going to be looking at basically the basic premise of a data scientist, which is visualizing data, preparing data, looking at trends in data, just basic exploration of data. So the idea is you have some data set. How can you basically package that data set to display the results that you get from any analysis to maybe somebody who has no idea about what data science is, or who has no technical expertise in whatever research you're conducting. So it's kind of, this might be a little bit repetitive to some of you all, but please bear with me. At some point, hopefully you will get something from today and tomorrow's lecture. So before we get started, let me just walk us through what I envision as the high level idea of the today and tomorrow's lecture, or conversation, if you will. Let me see if I have Dex up too. There we go. Okay, so at a high level, what we're going to be looking at is the following. So first day, we will start off with the, actually, I think what we need to start off, we start off with pandas. So the basic premise is we want to be able to manipulate our data, get some trends from the data. And we can do this so many ways. So one of the ways in which we can do this is by using a library known as pandas. I believe in other programming languages other than Python, you can probably use other tools, and there's Stata, there's SAS, but and there are a ton of tools that we can use. But for the purpose of our demonstration or conversation, we are going to be using Python, and we're going to be using the library called Pandas. And we'll go over some of the basic premise of pandas, how to read data, how to basically segment data, how to filter data, how to merge multiple tables together, and so forth. So once we're done with that, what I like the class to be very hands-on. So once I'm done talking and going over some of these materials with y'all, there will be an exercise which will take about maybe 15-20 minutes. But the idea here is to give you all more hands-on experience and not just only me talking. By the way, there will be some exercises embedded inside of the conversation, so you will get that hands-on experience regardless. So right after that, we have the visualization portion. So once we've made some analysis, we kind of understand what our data set looks like. We've done some computation with the data. It's now rightfully so that we visualize the data. We understand trends visually. Visualization is a good way of displaying data, and also a good way of giving people with no technical experience in the subject area a sense of what your results look like. So we are going to be looking at some of the ways we can visualize data in Python. And there are some libraries that are specific to Python. Some of it is what we call matplotlib. We also have another one called plotly. And finally, we have one called Seaborn. So we're going to be looking at some ways in which we can create beautiful charts, different types of charts in these using these libraries. And at the end, also, we have a visualization exercise. So this is my goal for today. I typically don't think we might cover all of this today, but as time permits, we'll try as much as possible. If not, we'll just continue from wherever we stop for tomorrow. I do also have what we call a Python refresher, just because some of y'all probably haven't had as much experience with Python. So the first portion is a Python refresher. We're not going to go into that. I believe last week we had a course on Python. So this is just kind of repeating what we talked about, the video that was played last week. And also we have TA sessions. So there are TA sessions set up. So if you have questions about Python, please feel free to ask the TA and also come in for one of those sessions. And also feel free to reach out to me as well. Okay, so that's it for today. And then we have the part 2 also. You can see the breakdown as well. Yeah, so let's get started. Before we get started, we need to do a little bit of setup. I want to say most of you are somewhat, we've introduced the whole notion of Git repository and downloading from Git, but I will go over some of the requirements or some of the things we need to do to set up. So there are 2 ways in which you can follow through with the exercises or just follow through with the class today. The first way is by downloading the repository on GitHub. So on GitHub, we host all of the modules that we create. And one of this week's lecture is, or this week's conversation is going to be hosted on GitHub. All of the solutions, everything is on GitHub. So if you head over to GitHub, I am going to paste the link in a sec, but we have a GitHub repository and it's called VADSTI Fall Series, where we have all of the materials from the pre-training session to our live interactive section today as well. So what I want each and every one of you to do is to go over to the GitHub link, which I'm going to post in a minute. Okay, so I just posted that GitHub link on the chat. You can, so the first way you can either, let me see. Okay, see this. You know what, actually that might not be a good idea. Okay, so let's do this instead, sorry. Excuse me. So actually ignore the first link, just follow the second link. So just go on the second link, which should take you to the root of the GitHub file. And what you want to do once you are on that web page, you want to click on the portion that says code, and then you can download the zip. So you could just click on download zip, and what that does is it downloads all of the files contained in the GitHub repository. So this is kind of like the easiest way to follow through with what we're going to be going through in this conversation. So once that's downloaded, let me see, seems like it takes a little bit of time to download. For those of you who are quite familiar with like with doing like the GitHub clone, you might just also use that as well. You don't have to follow this. You can just clone the repo and just go into module 1. But for those of you who have no experience with GitHub, this is the easiest way of just downloading the file from GitHub without having to clone a repository or some other complicated technique for navigating through GitHub. All right, so while we wait for this to download, let's see. Okay, it's taking exceptionally slow time. Has anyone had success downloading this faster than I am? Just wondering if it's my internet or it's just maybe it's a large amount of file.
I was able to download it.
Okay, so I'm guessing it's my internet connection. Okay, thank you. All right, so I will just stop this then. All right, so once you're able to download that, what you want to do is you want, so you have all of the pre-training as well as the today's conversation on your computer. Once you do that, then you can head over to Anaconda. By show of hands, does anyone have issues installing Anaconda? Because I believe this was done like maybe the pre-training module, one of the pre-training modules, we had to install Anaconda. If you have issues installing, we can go over that again. Okay. All right, seems like nobody has any issue with that. So we all have it Anaconda installed. Awesome. Okay, so can we briefly, yeah, sure. It's really not that complicated. All you have to do is just say download. That's how yeah, just go on Google Anaconda download. You go to the actual web page and then you can download it. Automatically identifies your computer system and gives you a download link. For me, I'm using a Mac, so I could basically just download it here. I'm not going to do that because I already have it. So for you, if you don't have Anaconda installed, just quickly download that. And once you download that, it stores it looking something like this on your computer. Where is it? Just one sec.
Can you use mini Conda instead of Anaconda?
I want to say yes, as long as you can get Jupyter Notebook on there. Yeah, that's fine.
Yeah, because Anaconda is such a memory hog and it's just chugging.
Yeah. You can definitely use mini Conda, whatever takes you to Jupyter Notebook. Yeah, you can use that. I haven't used that before, but you can definitely. Yeah. All right. So I have Anaconda installed. Just give me 1 second. Pull that to the actual page. All right. Okay, so this is what mine looks like once you've successfully installed Anaconda. Should look something like this. Again, if you have experience with other platforms, what we're trying to get at is Jupyter Notebook. So It doesn't really matter if you install Anaconda, as long as you're able to get there, it's fine. So once you have this, we just launch our Jupyter Notebook. And this is more or less like a web-based tool where you can display your Python code. It displays it in a cell format. So it's really good for teaching. Outside of teaching, I wouldn't really, but for teaching and learning, this is a good environment for displaying info. All right, so we navigate to our where we have our exact folder. So the folder you've downloaded here, you have your VADSTI fall series somewhere in your computer. I'm guessing it's on your downloads, and just basically try to navigate to that from your the Anaconda file. So how did we even get here? So let me back up a little bit and just go back and go through the steps again for those of you. So once you open the Jupyter Notebook, you should see all of your directories. And let me actually open this again. So this is what you see when you open that. I'm just gonna, I think I already have it open somewhere. The folder that I'm going to be using today. But for you all, you would have to navigate to that folder. I think it should be downloads and then look for whatever the name of that folder is. I think it's VADSTI fall series. So, and then once you get on VADSTI fall series, you want to click on the module 1. So that's where the file that contains all of the files we're going to be using. I have mine slightly different from y'all's, but it's pretty much the same idea. If you have any questions, by the way, just kind of send it over in the chat. I try as much as possible to look at the chat as I talk. So thanks. All right, so so this is what mine looks like. Mine started in desktop, and I renamed it a little bit different, but once you navigate to that, you should see something similar to this, where you have pretty much the folder for the data set, which some of which we're going to be using for a demonstration in class. I think I want to say the exports is not there. You could just create that in the folder. So if you go to your directory, you could create all of the missing folders, and the reason why it's not there is because they're empty. So when we pushed to GitHub, we ignored all of the empty folders, so that's why I deleted all of them. So I think the export might not be there. Let me check. Yeah, so you don't have any of the extra folders that I do, but when we get to that portion, what you want to do is, sorry, excuse me. You want to create those folders, if you will, because we're going to be storing a figure in the export, I believe, at some point. But for right now, it doesn't really matter till we get to like the specific code segment. All right, so this is what that should look like. Let's go back to this, just check, see. We have this. All right. So mine is a little bit different because what I'm trying to do is at the end of this module, or at the end of the 2 days, I am going to post the solved notebook. So I have solutions to everything in here, but I took it away just so that we can attempt the questions ourselves. But I think it might not be a bad idea to post this actually, because this is more of a learning experience. So if you're struggling with anything, you could check the solution. So I probably will do that later on today. But yeah, so there is solution to all of the questions. I do have the solution, so I will post that. All right, so once you're done, you have the Python refresher, Pandas Basics.
Excuse me.
Yes.
I'm sorry, I've got an error on my, after I downloaded it, it said, and then I tried, went to the downloads and tried to open it in Jupyter, it says error. Zip is not UTF-8 encoded.
Oh, did anyone run into this issue, or is this just a? Okay, so
Yes, I did get this problem if I just link to the zip. But if you unzip it and save somewhere else, I solve the problem.
yeah. So one thing, yeah, that's one thing I need to mention. You need to unzip before you can click on it.
Oh.
Yes, sorry. Yeah, I should have mentioned that. Yeah. It's a zipped file. So when you download from the VADSTI file, or you download from GitHub, it comes in as a zip file, so you need to unzip before you can navigate to it. Yeah, that's actually a key thing. All right. So once you have this, you have the Python refresher, which I talked about earlier. We're not going to go into too much of that, but it's basically just giving you like high level overview of Python and some of the key components that are used in Python, some of the functionalities, and it's for your information. You can check it out at your leisure time. And if you have any questions, reach out to me or the TAs. We'll be more than happy to direct you to resources or help you out with the material. And then we have our Python basics, which is basically what we're going to start off with today. And then after the Python basics, we have our exercise. So pretty simple stuff, gives you like questions you should attempt, you should load the data set, and so forth. All right, so I'm not going to go over every of them. I kind of talked about them at a high level. Okay, so let's so this is one way of you get your environment set up locally, everything works, that's good. Another way, if for some reason this is not quite working out for you and you don't want to fall behind with our conversation, we provided another way for accessing some of the material, and this is using what we call Codio. So Codio is a platform that allows you to run a lot of the like Jupyter Notebook, Python, a lot of the programming languages on the web. So you go on to you sign up on Codio. We do have a course link that you need to get access to. Once you get access to that, you can basically look at the material. So I will send the course link in the chat in a sec. Let's see. Okay, so send in the course link. So I just pasted the course link on the chat. So once you click on that, you should see something like what I have on my screen. So it basically gives you all of the modules and like the course instructors. So for today, we are looking at module 1, which is over highlighted. So once you click on that, I think for most of you, if you haven't had access to Codio, it's going to ask you to sign up, have a username, have a password, and all this stuff. But once you sign up, it just directs you to the same screen that I have. So for this, once you click on the module 1, it should take you to something similar to what you have on your GitHub, what we just showed on GitHub. So here we have all of the files similar to that, what you have on Jupyter Notebook rather. So you can navigate to the respective files, and you can pretty much follow through with the exercises as well. So this is if you don't have access to Anaconda, or you don't have access to the GitHub or some of the stuff we just talked about earlier, you can follow through using Codio. Okay, so I'm going to pause for a sec to ask, are there any questions so far? If you have any questions, please feel free to ask at this point. Okay, if there are no questions, let's get started with today's convo. All right, so I'm going to head over back to the Jupyter Notebook. And what we are going to start off with is the Pandas Basics. Okay, so like I said earlier, the main idea or the main goal of today and tomorrow's conversation is introducing you all to some of the techniques of analyzing data, exploring data using the tool called Pandas. So as data scientists, one of the main key thing is being able to translate or analyze your data and translate it into insights that a consumer or someone with no experience, technical experience as you, can efficiently understand and digest that info. And some of the ways we do this is by using tools to basically find insights in our data, or by using visualization tools to basically present that data such that people can visualize the data and basically understand the trends or insights that we're trying to translate. So in order for us to do this, there's so many ways in which we can get this done. Some of you are probably very proficient with R or proficient with SAS, Stata. There are just a plethora of tools that are out there to analyze data or visualize data. But in the last decade or so, you can see that Python has become one of the standard way of analyzing data. Back in the day, it used to be SAS, maybe Stata, but slowly, most people are slowly switching to R and Python. So with that being said, for the duration of our conversation, we are going to be looking at some of the ways in which we can achieve this using Python, in Python rather. And in Python, the premier tool or premier library in which we are able to analyze data as data scientists is Pandas. What is Pandas, you might ask? So Pandas is pretty much a tool. It's a library, so we necessarily don't call it, it's not a programming language, it's a library. So Python is the programming language, Pandas is the library that allows us to basically analyze data. So we have our data distributed in tables, and we load that data into Pandas. Pandas is that library that a bunch of people wrote in order for us to analyze data. Basically, all the things we can do in SAS and Stata, we can basically use Pandas for pretty much most of it, I would say. I would argue all can be done using this powerful library called Pandas and Python programming language. Is there a question in the chat? Okay, no question. All right. Okay, so just like every other module in Python or every other library in Python, we need to, in order for us to use it, we need to import that library. So Pandas is not any different. So, one thing I need to also iterate with Pandas, you can think of it kind of like a CSV or Excel spreadsheet where you have tons and tons of data, you import it into this library called Pandas, and it looks basically like a long Excel spreadsheet. But Pandas comes with a set of function that allows you to manipulate that Excel spreadsheet and maybe perform certain actions to it. Maybe you're looking to combine multiple Excel spreadsheets together, or you're looking to get the mean or the average or the standard deviation of a data set, or you're looking to transform your data set such that you can calculate maybe the exponential progression or some fancy math. All of that can be done in Pandas library. So using that data, the data frame, what we call a data frame, which is kind of like the Excel spreadsheet in Pandas. Okay, so moving back to the question of how do we actually get this library in Python. So with every library that we use, we first need to import the library. Before we get to importing, there are a couple of things we need to do. First, we need to make sure that we even have that library installed locally on our system. And the first step is to install the library. So don't worry too much about what this command is, but this command basically talks about how we install. So this is more of a Linux command. And what this does is once we run this, it basically installs the Pandas library in our computer. So what I would do is just run this. So you go over here, you see the run command, hit that. Let me see, it does have a password. What's that? Let's see, sudo pips. No, I'm not going to do that. For some reason, when you do sudo, it asks for a password. So what I'll do is I'll just take that out and then run. Let's see. Let's see, start. Okay, so for those of you who are don't want to put a password, you just go and take that sudo out and just put pip3 install. Since you're running that locally, it should work with no issues, I believe, because sometimes when you're actually demoing stuff, things just go crazy. So yeah. All right, so that command basically runs the installs pandas if you don't already have it. I think I do have it, so it was just kind of reinstalling again. So once you run that command, you have pandas library in your Python. You have the module installed in your Python version. So with that, once you do that, then once you have pandas, you can then use pandas. Without that, if I just didn't have this command or I don't have pandas installed and I try to import that module or import that library, this will give me an error. So first you have to install the library in Python in your Python module before you can reference that. Okay, so next step is now we run the pandas, we import that into our module. Again, Jupyter Notebook is very good for teaching and also for illustration, where we can run column by column. So the way it works is, if you notice, we have the first column to run, which is this pip3 install pandas, and you can read the material that comes with that. And then the next column is in line 4, where you can also read the material before that. So there's a little text that illustrates the code, followed by the code, and a little text as well. So it kind of gives you, even without me being following through the instruction, you can kind of get a sense of what the lecture is talking about, the conversation is talking about. So that's one of the beauty of the of Jupyter Notebook. Okay, so let's go ahead and run this as well. Okay, so what we just did with that is we successfully imported pandas into our program. We haven't talked about this as well, but we do need this for some of the program that we will be seeing at a later time. But what this does is Numpy is a mathematical library that allows us to perform some kinds of mathematical functions because we will be looking at maybe creating a array of numbers or doing some kind of mathematical array multiplication. We can use this library. We will be using this library at some point, but that's basically what this library does. It allows us to do some kind of mathematical operation on even the data frame as well. Okay, so this is not necessary, but this right here is just demonstrating that we want the maximum number of rows to be 10. Using Jupyter Notebook, do we run all analysis on local computer or server? Yeah, Jupyter Notebook has a local server. So the way it works, it creates a local server on your computer and runs it via your web browser. So all of the analysis is run locally, not on some remote server. It does create some local server, and then it's able to run this using your web browser. It's kind of a fancy, yeah. But to answer your question, it's not run on a remote server. It's run locally, actually. Okay, so this is not required, but yeah. So this is not required, but you can basically run this as well. What it does is sets the number of rows to 10. Okay. All right. So now we have our pandas set up. We have pandas installed. We have pandas imported into our code. So now let's see what we can do with the pandas library. Okay, so first thing we want to do, or the whole idea of using pandas, is we want to be able to import our data set and then perform some kind of fancy computation or look at trends. But the whole goal of pandas is to manipulate data. That's kind of the key premise with using pandas. So one thing we can do is we can either create data or we can import data. So just like you use your Excel spreadsheet and you can do all kinds of math computation, you can find the mean, you can find the average, you can do a whole bunch of other fancy stuff using macros and so forth. Pandas allows us to do that and even more. So one way of using pandas is by using a data frame. So basically you could think of a data frame as the Excel spreadsheet basically that we talked about. So the data frame basically has all of the rows and columns contained in your data set. So basically if you have a data set, you can have the number of rows, the number of columns, and you can import that into your pandas or using your panda library as a data frame. Okay, So if you go ahead and run the line 7, so for the purpose of demonstration, we are, instead of importing, we're going to do 2 things. We're going to import the data and we're going to create the data. So first, let's start off by creating the data set. So what I mean by creating is we just come up with a bunch of fictitious data and we generate a data frame based on that fictitious data. I am going to show you also how to import, say you have a data set that you're already working with, you could also import that into Pandas. And every notion of a data set is stored as a data frame. So you could think of a data frame as the data structure that is used to store our Excel spreadsheet, basically, in this Pandas library. So if you go ahead and run the 7, run that, what that does is it creates this data frame that has the rows and columns and stores it into this variable called data. We're going to look at what that looks like in a sec. Just give me 1 minute. Okay, so someone asks, what's the code to import an Excel sheet? We are going to come to that in a sec. Just hang on for a second. I'm going to answer your question in a sec. We do have ways we can import different data format into Pandas, but we're going to get to that in a sec. But before we do, let's get to the portion where we're creating random data set ourselves and storing that in a data frame. Before we get to that, can y'all give me a sec? I will be back in a sec. Okay. All right. So once we run this portion, you go hit the run button. You notice that it runs successfully. If there was an error, it would give us an error message. So say we take this out. Hit the run here, you get your error message. If it doesn't show you anything at the bottom, it means that it successfully ran. Sometimes we might not be displaying the output, so it has nothing to print out to the console, so it just moves to the next line. Is it allowed to create a data without variable names, giving a variable name later? No, you have to have the variable name. So if you take out the variable name, to answer your question, and you run this, it would give you an error. So you always have to have a variable name. You can, yeah. And again, you could also experiment. So here you try it out yourself, see what happens. You can create the object actually. You can create the data frame object, but I mean, I'm not sure what you want to do with that. It just prints out the object, which is the data frame. But you want to store that into a variable name that you could use for a later time. Oh, I see what you're saying. And give the variable name at a later time. No. So what it does, if you don't have a variable name, it basically just returns that out to the console. And you can really retrieve this at a later time. So you need a variable name to store the data so you can reference that at a later time. I'm guessing this is kind of like, it says, can we create a data frame from an object? So the way the data frame works is it creates, it uses a dictionary data structure. So I'm not sure what object you're referring to. If it's a dictionary data structure, you can create a data frame using a dictionary. Yeah. Okay, so it's like an array. So yes, you can, but you would have to somewhat re-engineer your array to be a dictionary. So you would have to have a key and a value. So you see how it's done here? This is an array of values, but the key here is the first name. So you can definitely create a data frame from an array of values, but you would have to re-engineer or tweak what your array looks like in order for it to conform to the dictionary data structure. But to answer your question, yes, you can definitely do that. Yeah. All right. So once we run that, we have a dictionary. We're not done with the data frame yet. So a data frame is technically can be created using a dictionary, but it's not completely a data frame yet. In order for us to get this as a data frame, we need to call this function here. So remember, PD here is basically the data frame object, the data frame library that we imported. So here we said import pandas library as PD. So we have a kind of a alias for the pandas library. So now we're referencing that pandas library and we're calling the data frame function. Basically what this does is when we pass this, then we create a data frame. So now we are passing the the dictionary into this data frame structure, and we call that df. So if you run this, it should run successfully with no errors and go to the next line. And now we can reference this data frame by calling the variable name df. So if we run this, we should get our data frame printed out for us. So this data frame is essentially this dictionary we have here. So the column name is first name, and we have the list of values. And then we have another column name, last name. We have the list of values that represent that. So we do this for also the column age, the column race, and the column gender. So basically what we have in this data variable is what is displayed as the data frame df.
I have a question.
Yeah,
Very
sure.
quickly. So technically the df is sort of like the name that you give the variable or the data set, right?
Yeah. I can change this to X. Yeah, this is just the name we give our data frame. Yeah. So this is creating a just creating some random data set from scratch by hand. This is how we can do that. So we want to just create a small data frame that contains the column, first name, last name, age, race, and gender. And these are the associated values with those columns. So for first name, we have Juan, Ramiro, Gidget, and Saul. And then we also have other last name, we have the values and so forth. And we can create this and then turn this into a data frame. So this is a way we can create our data frame from scratch. So this is one way. So you don't have a data set, you just want to create something from scratch. This is how to do it.
I have a follow-up question.
Yeah, sure.
So to do the columns, you always put the name and the colon afterwards? Is that like the general, is that going to be the format we always use?
Yes, because this is a dictionary and this is how we create dictionary values. Not to bore you all with the technical details, but what this is what we call a dictionary. It's specific to Python data, Python programming language. And basically what it does, it has a key value pairing. So this is what we call the key and then the associated value. So every time you have a key, it's followed by a column and an associated value. So in this case, our associated value is a list of values. But to answer your question, every time we're creating a data frame from scratch, we have values, you always have to have the column name followed by a colon and then the associated list of values that we store into a data frame, into a dictionary. And then we convert that dictionary into a data frame using this code segment here. We store that into the data frame name df. And then we could reference that df at any point in our program. So now, instead of saying this, if we want the data frame, we could call this at some point.
I have another quick, I have a question just to follow up on what she said. Let's say that you're importing the data. Will the Python automatically distinguish like this is a column, right?
Good question. We're about to get to that in a sec. Like really, but yes, Python. There are ways in which we distinguish the column. We use like the delimiters, and we'll get to that in a sec. Yeah. Okay.
So I have another question. So,
yeah, sure.
So you can always just type the data frame name to show the data. Is that right?
Yes, because
so what's the difference between just type the data name versus print?
Oh, okay.
Print of df.
So print out df prints that to the console. Technically, there's not like a clear distinction. You can do this, that's fine, but it doesn't return it as a data frame though. This just prints it out to the console. So if you do print df, this is what this looks like. It prints out the text values to the output file. So you can do this, there's nothing wrong with this, but just saying df, it returns a data frame object. So you notice that they're actually slightly different in the way they're returned. One is returning a data frame object, the other is printing out to the output console. And also you look at the way this is just a text, but the other one, when we do df, it's returning an actual data frame. So it's more technical than anything. You could do just print df if you want. You could say df, but with the print df, if you say print df, you can use that data frame in an instance. It just returns what you have there to the console. I don't know if that answers your question, but that's kind of like what.
So actually, I was trying to see like if we have like really long data, with a large number of records. So it's just print all of them, or if you say df, just like show the first
Oh, yeah,
several
so
rows.
good question. So we will get to that in a sec, but yes, if you do df, it shows like it truncates it. It can print, it can show everything. It truncates it. So I don't wanna, maybe we're getting ahead a little bit. But let me see if I have something that shows that here. Okay, let's just use this random example. Here, this has 1,170 records. You can see it truncates it when it displays like the returned data frame. It doesn't show everything, but if you do print df, I think it also truncates it as well to display. So your best bet is saving that data frame into a CSV or file where you can fully display all of the records. Yeah.
Thank you.
Where are we? Okay. So, okay. Again, please feel free to interrupt at any point in time and ask a question if you do. I do like conversations. So that's why I don't call it, I try to stay away from the word lecture, even though I occasionally say it, but this is actually a conversation as opposed to a lecture. So yes, please feel free to interject, add to the conversation, whatever the case is. I'm always happy to have that engaging discussion. All right, so basically, once we run this, we get the data frame returned to us. So this is just us creating random stuff. All right, you could also rename the data frame. Okay, so there's a question that says how to print values for a given date in the data frame. So values for a given date. So is it you have a date column? Francis, is it you have a date column? Can you I'm not sure I quite follow that question. Okay. Oh yeah, so you can definitely filter by date. We haven't gone to the filter portion yet, but it's good to see that everyone's thinking ahead. So that's great. I'm guessing this is very interesting lecture that people are starting to think about so many things you can do with the data frame. Yes, but to answer your question, you can definitely select a range of date values, and you can retrieve data based on those date values. We will get to filtering data in a sec. Okay, so so you could also do things like you could change while you are creating that data frame. You can change the column headers. So here we had first name, last name, age, race, and gender. Say we, for some reason, we want to change it. So while we create this data frame, we could also change that value. So here is a repeat of the original data frame using the dictionary, the data dictionary. Remember the data dictionary right here? But here we just store that into a data frame. So here we can say, hey, I want to store it in a data frame, but I also want to change the headers, the column headings. So if you run this, df changes now, or actually the index. You could also change the columns, I believe. Let me see. Maybe columns. Yeah, you could do that too, but let's just leave that. You could change the index as well. So in this instance, instead of having index 0 to okay, so the question is, so index is equal row. Yes, yeah, that is correct. So is index a part of the data? Yeah, well, you could say index is a part of data. So it's the row. So instead of saying row 0, row 1, row 2, you can say index 0, index 1, index 2. Just like when you have an array of values, and then index 0 is the first instance of the value, index 1. So that's the same logic here. Okay, so you could change the index. Instead of having your typical 0 to n-1, you could change it to whatever default values you want. So here you run that, and the indexes, instead of 0, it becomes what you specify. If exploring a CSV, does it show in Excel spreadsheet? No, it doesn't. It doesn't. You import it to the Pandas library, and we'll look at how to explore CSV in a sec. Just hold all the questions about exploring CSV in Excel just in a sec, like a quick sec. We literally get into that. Okay, so you can basically convert the typical 0, 1, 2, 3 index into specified default index values, and you can search based on those index values. So in this instance, we want all of the, we want all of the values for the index MRN245. So we can search, we haven't talked about this LOC, but what that does is it's a locate function, and it locates a specific index. So how you can have like an array of values and you want to reference a specific index. So you have an array from 0 to n-1, and I say, I want to locate index 5 in the array. So this is kind of like what that LOC function does. So when we pass in the index value, it returns the row containing that index value. So here we have Ramiro. So MRN245 is this row. So it returns all of the values for the columns of that row. So these are some little fancy things you can do. There are a bunch of things you can do, and we're going to get to some of them. We cannot complete everything in a 2-day series, but what we're going to try to do is to give as much materials as possible that can serve as building blocks for you to go on and learn some more on your own, because there's just a ton of things you can do using the Pandas data frame that we cannot complete in just a day. Okay, so now we talk about we want to just create some fictitious data. So say, for example, now you have your own data set. How do we import data into Pandas? Or say I have an Excel file that I've been looking at for a couple of weeks in Stata or SAS, and I'm like, you know what? I'm tired of using SAS. I'm tired of using Stata. I want to try out Pandas and see how that works. How do you import that data into Pandas? So the good news is yes, you can import into Pandas. You can import from a variety of formats, Excel, CSV. I think you can even do SPSS as well. You can do a host of formats, and you can bring all of that data into the Pandas data frame object. So let's look at how we can achieve this using Pandas. So first step is, if say, for example, we want to read a CSV, we want to read the data from a CSV. So what we do is we use the function read_CSV. So remember the PD right here is the alias that we named our Pandas data frame, our Pandas library. So when we imported Pandas into our Python program, we renamed that as PD. So instead of saying Pandas, we can just reference the PD name, and then we're basically having access to the Pandas library. So when we go down here, in order to import, we say pd.readCSV. So readCSV is the function that we call from the Pandas library. So read CSV, and we pass in the file name. So in this instance, we're getting some, I already have this data set stored in a location, and we're just gonna get that data into our Pandas or into our Python program. So before we do that, let's actually run this. And So we read that into the data frame, and we store the data frame as patients_df. Again, what we're doing is we have a CSV file. It's patients.csv. And what we want to do is, by the way, CSV just means comma separated value. Let me see if I can see that. So I have that stored here, and let's see. I'll just open one of the CSV files. So it looks a little confusing, but the basic idea is all of the data is separated by comma. So we have the date, comma, mmWR_week. So all of the data is separated by a comma. That's what the comma separated value is. You could also read this using Excel, I believe. You can import this using Excel and so forth. So going back to what we're doing, so here we want to import the patients.csv file. And then that has information about patients. I guess it's synthetic data about like some fictitious patient info in a fictitious hospital. So basically, in order for us to import using a CSV format, we call the pandas library dot read_CSV, and we pass in the path of the file. So if you have the file stored locally on your computer, the path will be different depending on what location the file is.
Question.
Yes.
So I
Yeah.
have it stored locally in my downloads, just downloads VADSTI in a VADSTI folder, and then it's there. What is like the format, the general format?
So it depends. Using a Unix, I think you can do something like this where you say downloads, and then you can start with the root directory downloads, and then maybe I don't know what the location is.
Yeah,
Something like this. You can pretty much get like a root directory, and then the downloads, and then / the page, whatever the name of the file is. But or you can another thing you can do is, let me see if this actually works. You can look at the file location. So if you go to the folder, you can see what the info. See if that actually does work before I say it. One sec. I'm just trying to look for an easier way for you to get the path of the file.
and it's in the zip also. Does that make a difference? Like I can't open the zip directly because it's so large, but I can.
No. Oh no, you have to unzip first before you can access. Yes, you can open that using pandas without unzipping. So you have to unzip the file before you can access. So you notice here, we're calling this from some remote location. It's because the file, it's one of those issues where you could have a large file and you don't want to store it locally. So you could just call that for, you could basically read from a remote location. But in order for you to be able to read, whether CSV, SPSS, whatever file format, you have to have that file stored in some location, and it has to be unzipped.
Okay, I'll do that. It was downloading when you were going over it at the beginning, so I'll work on that.
Okay, sounds good.
Thanks.
Yeah.
I have another question.
Yeah, sure.
So just make sure I understand the syntax. So read _CSV, and then you have the CNC data plus the patient.csv. So is that patient.csv just part of that data, just like tab of the data or something?
Yeah,
like that?
so if you go to this, it has a bunch of, let me see if I could go real quick. Not sure. I think the path might be wrong. Let me see. So this link, it changed the file, but the idea is because this is the root directory for that CNC, but inside of that, you have a bunch of other files. You have the patients.csv. Let me see. Actually, I downloaded that locally. You have all of this inside of it. So it doesn't know which one you're talking about. So you need the exact CSV file. In our case, we're looking at the patients.csv. So what we're doing is the plus sign is to concatenate these two strings. So this is more of a Python specific code thing where we take the string here and we concatenate that with that. We could also do this. We don't need that plus sign as well. We can just have it here and then we take this out. We take this out here. So this is way longer. So that's why we broke it down into two. Let me see, put this. Trying to scroll to the right. Excuse me. Okay, so I guess we don't need to scroll. So you notice here, this is the full path right here. This is the file that we're trying to access here. Yeah, so that was just saying this variable plus that file path, which is just more fancy way of concatenating two strings together. Yeah.
So if you use the CNC data plus patients.csv, so the CNC data should be in the working directory, right?
You said the CNC data? No, this is from a remote location. This is a website. So it's a website.
Right, but if you want, like say, if you save it to your local folder.
Oh, I see what you're saying.
And if you specify a working directory, you don't have to specify the path, right?
Yeah. So if you specify a working directory, so you can specify, if you have this file locally, you don't have to specify anything. So if this file is, say, you have patients.csv stored in the same folder as this file, this pandas data, this Jupyter notebook, we can do this. We don't have to specify any path. If you have it stored somewhere in your computer, you can do something like this, download /patients or so, where you have the root directory / the download / the patient. But regardless of what you do, you just need to figure out what the path for the directory where the data set is stored. In order to avoid this, typically you want to store the Jupyter notebook, so this Pandas Basic notebook and the CSV file in the same directory. And then you don't even need to reference any path. You just say patients.csv.
Okay.
But if it's stored somewhere else, then you need to figure out what that exact path location is, and then copy that into the read CSV code or format.
Okay. So the folder you save the code is considered as the working directory, right? You don't have to specify. It's automatic. Not like in R, like you have set working directory, something like that.
No. If it's in the same directory, you don't have to specify. If they're both in the same directory, so the Jupyter notebook and the CSV files in the same directory, you don't have to specify. It's only when they're not in the same directory you have to specify the directory of the code that the file that you are importing.
Thank you.
Okay, so let's go ahead and run this and see what we, this is from a remote location. See. Okay, so when we run this, what that does is it imports the data frame, or imports the CSV file and converts it into a data frame and stores it in patient_df. Patient_df is the variable that contains the data frame for that CSV file. you can import not just CSV, you can import XLX, or what is the format? I think whatever the format for Excel spreadsheet are, you can import that. You can import SPSS as well. There are a wide host of formats you can import, data formats you can import, and not just only CSV. All right. So now let's see what is contained in the data frame. So there is a function called the head, and what that does is it returns the first 5 records of that data frame by default. So we call the data frame name .head, and it returns the first 5 records. So let's run that, see what that looks like. So you notice here, these are the first 5 records of the patients.csv file. Okay, let's pay close attention to this and see what we look at what we see from it. So we have the column ID. I'm guessing this is an identifier for each patient. We have their birth date, their death date. You notice in the death date, some of them are nan. What nan just signifies they're null, so they're missing. It has missing values. We'll talk about what we can do with some missing values as we progress. It does also have the social security, has driver's info, passport, and so forth. You notice here, it has 3 dots. What does this mean? Basically what this means is that we're not complete with the number of columns that are represented. So there are some missing columns that are not shown, but it's too large to fit in here, so it truncates a lot of the values. If it, I think it's maybe 10 or so, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. Okay, maybe not 10, but it does truncate the values when it exceeds a certain amount. So in this instance, it gives you the 3 dots to show that these are not all of the columns that are contained. You could also say, you could check to see, we'll talk about this in a sec, but you could basically check to see how many columns are contained by using the info keyword or the info function, and it returns all of the columns. So here we have 25 columns, 0 to 24, and these are all the columns that are contained in the data frame. Okay, so let's, so basically, if you want a quick peek at your data frame, you can just call the data frame name .head. You could also do .tail. Just as the name entails, it gives you the last 5 trailing columns in the data frame. So if you run this, these are the last 5 trailing columns. So you know, this is kind of like a way of just, you know, checking to see what's in your data frame. So first thing I do typically when I import my data to Pandas, maybe from Excel or CSV, I do a .head just to see what's in the data frame. So going back to importing, like I said earlier, you can import in Excel, you can import in SPSS, you can import JSON, and not just only CSV. So I want us to be clear on that. So it allows for a host of import, for us to import from multiple sources and not just a fixed Excel spreadsheet. Okay, so you could also just view all of the columns. One way is by doing the .info. It gives you the columns. Another way you can view the columns is by saying the data frame .column. So remember, the variable in which we store the patient data frame is called patients_df. So you can visualize the columns by using that value. So here, when we say patients_df.columns, that returns a list of all the columns contained in our data frame. Excuse me. Okay, so now we're starting to, so just a quick recap of some of the things we've looked at. We've looked at the how to create random data. Say we want to do something in our, or we want to experiment and stuff. We can create our own data set using using the dictionary approach and converting that dictionary into a data frame. Say we have our data set and we want to import that into Pandas. We can directly import the data set, be in CSV format, in Excel format, in SPSS format, in JSON format, I believe XML as well. You can import in a variety of formats into Pandas data frame. And now once we've imported the data, we can start to use the specific libraries or the specific functions rather that are pertaining to Pandas to analyze this data. So we're going to be looking at the example patients, the patient's data set that we just imported to do some of these things. At some point, we're going to change the data set as well. Okay. So here, say for example, you have all of this columns and you're like, hey, I don't think I need all of this. I just want to look at specific columns. I don't want to look at all of the columns at once. How do I go about that? You can basically create a subset of the columns. So here we have a variable called calls, and we have a subset of the columns. So I just want to look at ID, I want to look at birth date, I want to look at date and SSN and gender. I can create another table, which is a subset of the original table. So here we have the simple or sample patient rather, which is a subset of the original patient's column. And it only contains these values, column values. So let's go ahead and run this. And then let's view what that looks like. So you notice here, this is slightly different from the original. It only contains the column ID, birth date, death date, SSN, and gender. So it's only a subset of the original data set. So you can basically shrink your data set this way. And you notice instead of having to overwrite the original data set, we can create a new data set by storing the subset of the original in this new data set. Okay, so now we're going to continue to look at like different ways in which we can manipulate the data. But say, for example, you want to you say, okay, I want to store this in the sample data set, this subset, back to a CSV or Excel. You can actually do that in Pandas as well. So now we can take this data frame and convert it back to a CSV. So how do we do that? It's pretty easy. What we say is, we just say the data frame name dot to underscore CSV. So just like we had the read underscore CSV, we can specify the to underscore CSV. And then we specify the path in which we want to save that. So don't forget, this is when we need the export folder. So for those of you who don't have this export folder, you want to go into the directory where the VADSTI fall series, and you want to create that export folder. Because if you run this portion, it's going to give you an error because you don't have that exports folder. Okay, so you could also, you don't have to save it there. You could just take this out as well, and then you can save it in your root directory just like this. But I like to just create this exports folder because it kind of organizes things for me. So here we have sample underscore patient dot to underscore CSV, and we have the location in which we want to store the file. So if I go ahead and run this, it runs successfully with no errors. And if I go to the export I should see that. So this is the file, the sub data set that was created. I clicked on it. It's a CSV format. So it has the ID column, has the birth date, death date, SSN, and gender. So in fact, you can basically create sub data set from your original data set in Pandas. So in this example, we've seen how we can go from 25 columns to 5 columns. And you can do this with like, not just only columns, you can do this with rows. You can have a subset of row based on rows of values as well. We are going to get into that at some point too. Okay, I don't know if maybe we should take a break at this point. John, please let me know when it's, you think.
Yes, I bet. Let's take a 10 minutes break. I think it's for 11:40 almost, and then we come back.
Okay.
I mean 12:37. We come back at 12:47.
Okay. All right. Sounds good. See y'all then. All right, welcome back. Let's get started. Let me look at the chat for a little bit. Okay, so I think there's one question. Javita, hello. So I am the instructor for the two, just for this week for the visualization. For the rest of the series, there would be other instructors. I think there's about like an instructor a week or so, or maybe one instructor might head to my lead 2 weeks series, but typically there is a change at some point. But I'll be more than happy to answer your questions outside of today's conversation. It could be you could send me an email. I will leave my email in the chat. Also, I'm available sometime later today by 5 p.m. or 4 to 5 to chat if you have any questions about Python or just data frame in general or pandas in general. Okay. All right, so let's get started. Just a quick recap of some of the things we've talked about so far. We've introduced the notion of pandas, which is a very powerful library in Python that allows us to analyze our data, kind of similar to some of the things we can do in SAS, SPSS. We can pretty much perform them using the library pandas and Python. So pandas is a way of basically putting our data into a tabular form, and then we can use the power of Python in combination with pandas library to perform pretty much everything we can do in SAS. So far we've looked at how to create a data from scratch. Say we want to test out some ideas, we can create a real quick data set ourselves. We've also looked at how to import data. So say, for example, you have a data set you've been working on in SPSS or in Excel, or maybe another format, and you want to import that to Pandas. You want to import that to our data frame using Pandas. We've looked at how some of the ways you can do that. So for the rest of today's conversation, we are going to be looking at some of the things you can do using the data frame. So how can you manipulate the data using that Pandas data frame? Okay, so I want to say we stopped where, okay, so we created the subset and we basically exported that to a CSV format. All right. So we've talked about how you view your data. So you can either use the head function or the tail function. The head function just displays like the first 5 by default. You can also specify if you want just 2 records displayed or 1 or 10. It's pretty much up to you. But by default, if you don't specify the parameter, it displays the first 5 records. Likewise, you can use the tail as well. It displays the last 5 records by default. You could specify if you want the last 10 records or the last 20 records as well. Yeah. I did also talk about the info. So now this is us looking at the data frame and looking at some of the functions that come with the data frame. Some of the things we can do to this tabular data set. We can do a whole lot of things. We can group the data. We can merge the data to another data set. We can basically slice the data such that we get subsets of the data and so forth. So going back to the patient's data, we could also check the number of columns in there and the data types of each column. What do I mean by data type? So sometimes columns store strings, store integers, store decimal numbers. We can look at what the data type of every specific column is by calling the info function. So we kind of looked at this earlier. So remember, we said the patient data frame contained 25 columns. we can see what the data types are. So D types here is referencing the data type. So when it says it's an object, it's pretty much a string. So all of these are strings, and then we have floating point numbers. These are just numbers. So these are numbers and these are strings. And then it gives us the column names for each respective columns contained in the data frame.
I have a questions here.
Yeah.
So looks like the df.info, it allowed the arguments in the parentheses. I just try like putting number, doesn't work. So what type of arguments we can put in the parentheses?
So typically when I use df.info, we don't put there's no parameters. I don't put in a parameter, but we can check what the standard documentation says. But typically when you use df.info, we don't include a parameter because for the use case, it's pretty much just relaying information about the columns and the data type. But to answer your question, I'm not specifically sure if you can include a parameter. Just because it has a parenthesis, it just means it's a function call.
Right, but what's the difference between the command with and without the parentheses? Because I try, for example, the df.column, that one doesn't allow a parenthesis. So you have to say df.column to see the column names.
You try df.what?
The one you showed before is you show the column name. So that one doesn't allow an argument.
Oh, I see what you're saying. So you're saying, what's the difference between this?
Right, because some of this,
right,
they need a parenthesis.
Okay.
Right? Some of them doesn't need. I mean, you have to not include the parenthesis.
Right. So yes, you're a good observation. Yes. So this is a function. You're calling a function. So the patients.df, and this gets into more technical Python description, but what this is, it's actually an object, a Python object. And then with an object, each object has associated functions. So one of the function that is defined for this object is known as the info function. And when you pass this, you call this, it returns the values that are assigned for that function. But you also can, when you call these are basically you're calling a specific field value in the object. So columns is a specific data field. Basically, when you have a class, you have the data fields, you have the functions, and so forth. But these are not functions. These are just like data fields. And what that does is it returns a list of values for that. So just to answer your question, some of when we call them and we don't pass in the parentheses, that just means those are data fields. And then when we pass in the parentheses, it means they're functions. And what they are, they're specific to Python object-oriented programming construct. So in Python, we have what we call, or just any object-oriented programming, we have what we call classes. And then we instantiate the classes by creating objects. So patients df is an object of the data frame class. And then sometimes we have functions that we can call in from that object. Info is one of those functions. And then column is a data type in that class or that object. So this is more specific to Python object-oriented implementation.
Right.
Yeah.
So that means you have to remember which one is a function, which one is a value type, something like that. Because syntax, there's no difference, all dots, right? You can do the data frame dot a function or data frame dot a.
Yeah.
So
yeah. Yeah, you are correct. So you have to remember which one is a function to include the parentheses or which one is just a data type. But yeah, that is correct. So yeah, I would say not all of them have the parentheses because you're not calling a function. And yeah. So like if you do this columns, I believe.
Yeah, I
So
tried, it doesn't work.
yeah. So that's just data. That's a data field. Yeah.
Thanks.
Okay. So the info basically just kind of returns the column names, their data types. So what I say data type, like are they a string, are they integer, and so forth. So this gives us a way of visually looking at what columns are contained and so forth. You could also use the columns to see the types of columns as well, which we did earlier. It just returns a list of all of the columns. Okay, so as a data scientist, or not just as someone who's curious about data, you have your data set, you import it. First thing you do is you probably want to check out what the data looks like. I typically just first start off by saying .head, and I just look at the first couple of columns, say what it looks like. I might also hit the info as well, just to see number of columns and what the types are. And then, from there, it gives me a sense of what the data set looks like. Also, another thing, I might look at missing values, but we'll get to all of that. We're just kind of introducing some of the functionalities of Pandas right now. We'll get, hopefully, if time permits, maybe end of today or tomorrow, we'll get to how we can actually methodically go through series of steps of analyzing data using Pandas data frame. Okay, so say for example, you're curious of the dimension of your table. For some reason, you want to know what's the number of rows and number of columns. There is a provided data type that we can use. It's called the shape.shape. So again, it kind of reiterates what we talked about earlier. This is not a function. This is just a data field, rather data field, not type, data field. And what this does is it returns a tuple of the number of rows and columns contained in that data frame. So if we go ahead and run this, it returns a tuple. This is known as a tuple because it has a parentheses in there. So a tuple is a two-value pairing. For those of you who were at the intro to Python pre-training, you notice we talked about tuples there. So here, what this is saying is we have 1,171 columns, and then rows rather, and then 25 columns. You can also, you don't necessarily need this. You can see this from here too. So if I do this, I can also get that value. So if I say head and I run this, I can get the value as well at the end. Let me see. So sorry. If I run this patient's DF without seeing like head or anything, I can get the number of rows and columns, the total number of rows and columns of that specific data frame. And also you notice with this, it truncates it. So it gives the first 5 and also the last 5. So it's like the head and the tail, basically. And then in between, it just gives you a dot that shows that you have more info there as well. So the shape is used to get the dimensions of the data frame. Okay, so also I'm interested in solely just the data types. I can say, I want to know what are the data types of the columns. I could also say call the dot D types data field, and or you could say attributes or data field, and that returns for each column. It tells me what's the type. Is it a string? Is it an integer, and so forth. You could also, you don't necessarily, so one thing you notice about this is that there are multiple ways of solving a problem. You don't necessarily have to use the same method. So .info gives you the column and the types in combination with other things. So here it gives you the non-null values, the total number of values for each column that are non-null. So you can get a lot more description from the info, but the D type just gives you the data types of the columns. So you can basically get that info from here as well. Okay, so let's talk about missing values. Very key portion as a data scientist. One of the main thing we do as data scientists is we analyze data and we look at the data for trends. And in order for us to do this, we have to make sure that we clean our data such that we can use that data set to perform analysis. So a key component of our analysis is to hunt or to look for missing data. So Pandas does allow you to look at missing data or to basically analyze or check to see if a data is missing. Before we get into getting the total number of missing data, one thing we can do is we can basically return a data frame, a Boolean value of if a specific value in a data frame is missing. How do we do this? We use the isNull function. So isNull function just returns the same data frame, but it returns true or false. It returns false if that data frame is not missing, if the value in that specific index is not missing, and returns true if the value is missing. So let's do this first. Let's take out the isNull and let's run this first. So this is the patient data frame that we had from earlier. We see that the death's date is missing for each record, for most records, basically. So now if we put in the isNull function, or we call the isNull function in that data frame, and we run that, you notice it gives us just true and false, a bunch of false, basically. But if you look at the date column, it's a bunch of trues, pretty much. And it only returns true where you have the missing values, where you have the null values. So what the isNull does is it just checks to see if that specific value is null. If it's null, it returns true. If it's not null, it returns false. Okay, so some of you might be thinking, okay, I know this is null. Okay, how can I use this to check the number of missing values? How does this actually help me? So to answer that question, you can sum up the number of missing values for each column by using the sum function. So now that we know we can return a Boolean values of all the null values and so forth, we can call the sum function. So the sum function, what that does, it's an aggregate function that returns the sum of the data frame. So just out of curiosity, let's do this first. Let's take out the isNull from this function and just run the sum. So this is just out of curiosity. You notice here what this tries to do is it tries to sum basically all of the columns together. So this sum function, what it does is it tries to sum all of the columns together, even the integer, the string columns. You notice here what it's doing, it's combining all of the columns, even the ones that are strings and so forth. You see here, the zip, it combines all of the zip. It gives you the total of each column. So we take that and we also, instead of just summing all of the columns, we check to see if that column is null or not, and then we call the sum function on the result. So if you run this, what you would see is the number of null values for each column. So going through each column, the ID has no null values, birthday has no null values. In the that date column, we have 1,000 null values. Drivers column, we also have 213 null values and so forth. So this sum basically gives us all of the null values that are contained. You notice here, because we have 25 columns, it gives a dot. However, if the column is null, it displays the null values for it. So a question you might have is, how am I so sure that the ones that are in the dot that are truncated are not null values because it just omitted them? The answer is, if it in fact contains a null value, by default, it would return that value as one of the columns that are represented here. So the ones that are truncated, in fact, do not have null values. Right. So this is one quick and easy way of basically checking for null values. So you've imported your data set, maybe you've gotten a subset of the data or whatever the case might be. And the next step is, I want to analyze this data to look at trends or patterns, or I want to estimate whatever the case is. And the first thing is you want to do is you want to say, are there null values in my data? I want to clean my data set up. So I want to first track down the null values and do things with the null values, or delete, or whatever your process is. Maybe get the average, and we'll look at some of the things we can do with null values. But for right now, we're just looking at some of the functionalities of Pandas data frame. So basically, this is a quick and easy way of checking for null values. And with null values, sometimes we might want to delete them. Sometimes we might want to get the average, or whatever the case is. One way of dealing with them is by removing the null values. So how do we remove the null values? So with the data frame, you just say drop NA. So point of caution with this. When you drop the NA, what does that actually do? So when you point and say drop the NA, this basically drops every row and column containing null values. Because if you notice here, we had 25 columns initially. And then when we issue the drop NA, without specifying if we want to only drop the columns that have null values or the rows, this in fact drops every row and column. Whenever it sees null values in that column, it just deletes everything. Whenever it sees null values in the row, it deletes everything. So you notice that this reduces the column space to 17. So if we go ahead and run this, so now, as opposed to 25, we have 17 columns. And why is this? Because by default, when you just specify without specifying if you want to only delete by the rows or you want to delete by the columns, it drops anything that has null values, whether column or rows. So here we've reduced the space to what's it called? Let me see, maybe not. We've reduced the rows to 2, I believe. Yeah. Drop the null values. Okay. Yeah. So drop null values, it drops the rows rather, drops the rows that have null values by default when you specify drop NA. Correction, by the way, not the columns, just the rows, because when we run this, it still gives us the 25 and as opposed to 17. Also, you can specify if you want to just drop by column or you want to drop by row. You can specify by saying axis equals 1, which means that you want to drop by column. So in the drop NA parameter, you can specify the axis. So axis equals 1 means column, axis equals 0 means row. You could also type that out. They've made certain updates to pandas where you don't have to only say 0 and 1. You can say column, you could say row as well. So you could say axis equals row or axis equals column. I think it might be rows, but let's check. Okay, rows rather. Let's make sure this is okay. Sorry. Yeah. So axis equals columns. You have to put the strings, not just columns rather. String value, or you could say axis equals rows. And that would do the same thing as saying axis equals 1 for columns and axis equals 0 for rows. So what this is doing here is it's dropping based on the row axis, or let's just go back here. It's dropping based on the column axis, all of the columns that contain null values, and it's returning the shape. So remember, when we say shape, it gives us the dimensions. So instead of seeing the entire data frame, we only just get in the dimensions. We can take this out and we can run this, and it gives us the entire data frame with the drop values. One thing I do want to mention is that what this does when you use the drop NA, it returns the data frame. It does not save this in place. It just returns that data frame. In order to save it, you could basically rewrite the data frame. So you could say something like this, and it saves it this way. But if you just run this code, what this does, it returns that data frame. Your original patients.df is not affected by this. So it's one interesting thing about pandas. When you don't save it into a variable, it just only returns that data frame, the table. It doesn't alter this patients_df.
So just to make sure, so the code return the one after the NA being removed, right? Not the one being removed.
It returns the one after, yes.
After remove the NAs, right?
Yes, yes, yes. So if you run this, it would return whatever the values are after all of the rows, all of the column, the null values in the columns have been dropped. Those columns will be dropped that have null values. So the date, what's it called? The date, the dead date will be dropped because it has null value. So any column that contains null value will be dropped based on this code.
So here it basically means we end up with only 2 rows without NA.
Right, whatever, yeah, whatever that case is. I'm not sure. Let me see.
The 154.
No, we actually have 3 rows. 1, 2, 3. No, 3 columns rather. 1, 2, 3. So for this instance, where is it? Yeah, for this instance, we would have 3 columns deleted because
right,
it's
but the one before that, you remove the rows that only have 2 rows left there after remove the NAs, right?
Let me see.
Because it showed 2 rows, 25 columns.
Yeah. So yeah. I'm thinking, yeah, that's the only rows that don't have null values. So every row has a null value in this, because if you look at this, there's 1,000 for dead date. So that's a lot. And then there's 213. So the only rows that don't have null values are this. Does that answer your question, or is there?
Yes. I think another question is blank allowed? If blank is allowed, is blank considered as a null value?
Great question. So blank is allowed, just a space, a string. So a string is not a null value. A null value just means missing value. Like the computer has no collection of what the value is for that specific field. So you can have a missing space, you can have just an empty space. That is still a value. An empty space is still a value, but a null just means like, hey, I don't know what it's supposed to be in here, or maybe a corrupt file or corrupt value, but a null value is not the same as a blank value.
So in Python, the null value has to be denoted by NaN?
In Pandas data frame, yes, it
has to be
denoted by-
NaN,
yes,
right?
yes. Mhm. Right. Okay. So basically when we remove, you can remove by column, you can remove by rows, you could specify the word columns or rows, either one. I typically like to specify them just because the ones and zeros can be a little confusing. Yeah. Okay. Okay, so now that we know how to delete null values by either rows or columns, another thing we can do is, say, for example, you have a bunch of nulls, and for some reason you just don't want to delete them. You could also, one thing you can do is you can fill the null values with a specific value. So say, for example, you don't want them to be null anymore, you just want to fill them with a bunch of zeros, or you want to fill them with like a string or some value you might think of based on your analysis. Pandas does allow you to do that. So say, let's going back to the example we have here of the data frame. What are some of the things we can do with this? Just fill in the value. So here we are specifically just looking at the zip column. So one thing I might have not talked about earlier is you can basically filter by a specific column. So this returns only the zip column, which is a column in the patient's data frame. So this is just that one column. So you could basically check to see the total number of null values for that specific column. We have 543 values for the zip column, which we saw earlier when we did the sum, right here, 543. Going back to just that specific column, where is it? We have 543 as well. So now, say, for example, we want to just modify and fill all the null values with a specific value. In this case, it's UNK. You can fill it with zeros. You can fill it with zeros, you can fill it with whatever. But say, for example, we just want to fill it with UNK. To do this, we can say, segment just that column, and we say fill NA UNK. And what this does is it returns, again, it does not store it in place. You have to save it yourself to store it. So you would do something like patients df zip equals patients df. So you would have to restore this yourself. But what this does is it returns the values where you change all the null values to unknown. So instead of having all the nulls, it basically changes all the null values to UNK. So in this instance, we typically would have unknown here, but it changed that to a UNK. You could also, instead of using the UNK, you could say 0 as well. See that? Run. Right. So basically, this is the key word to rename or to fill all of the null values with a specific string. So here we say fill NA and then we pass in the string name, or we could say pass in a value. So like I said earlier, it does not change the original data frame. This is not done in place. There are ways in which you can do it in place, but the easiest way to do it, to rename or to change the values, is to rename the variable. So in this case, we say patient_zip equals patient underscore df zip dot fill NA, and fill in the values of the null values to unknown, UNK. So now let's check to see if we still have null values once we've run this. So when we run this code, it returns 0. What does that mean? It means that we've changed all the null values to a string called UNK, and we no longer have null values in this column. It does not mean that we don't have null values in the data frame, but for the zip column, we've succeeded in changing the null values. Another thing you can do is, say you don't want to just specifically fixate on a column, you can change the null values across all of the data frame. That is pretty easy. So I am going to add a new column to this Jupyter notebook. How do you do that? You hit the plus sign over here, and it gives you a brand new column where you could add code to. So here, what I want to do is I want to change the data frame. I want to rename all of the null values in the data frame. So instead of saying, using just the zip column, I could say patients_df dot fill NA, and then put in the same keyword that I had for the earlier one. So when I run this, it changes all of the null values to the UNK. So remember the death date that has a bunch of null values, NaN, it's changed everything to the UNK. So this is a way of just doing this across the entire data frame, as opposed to just one specific column. Okay, let's check the chat. Is it possible to reference a row like you've done in columns? Yes, it is possible. So you can reference a row. I want to say we have that somewhere here. Let's see. Okay, that is not here. So I will try to bring some material on that next for tomorrow's class. But yes, I can show you really quick. You can reference a row. Basically, to reference a row, you can specify the data frame, and then you could say you could use the LOC keyword, and then you could specify the row number. Let me see. This basically just returns, let me see, that returns that row. You could also do this as well. It's an index. It should work, maybe not. Let's see, patients DF. I think I locate, and yeah. So I mean, there are multiple ways of referencing like a specific row. Like I just want to return just that one row. Interesting. This doesn't work. Yeah. All right. We'll get into specifics, the different ways you can do that next class tomorrow. I'll try to include more material on that. I thought I did, but I guess I did not. It's not here. That's interesting. Okay, so I'm gonna get to that for tomorrow's class. But you can definitely reference a row. You can reference a list of rows and so forth. Says, can we do the reverse that is set a null back to null. Yeah, I want to say probably, but I haven't done that before. Like reversing the nulls, the values back to null. But yes, you could definitely set values to null. I don't see why not. Yeah. Okay, patients fill in a code. This is a code to use to change the yes. Yes. So if you have that data frame, instead of just specifically changing a column, all the null values in the column, you can definitely do that across all of the data frame. And you could just call the patients_df.fillNA UNK or whatever value you want to pass across to change the null values. And you could do that across the data frame as opposed to just one specific column. So yes, to answer your question, yes. Okay, so where are we? All right, so basically we can rename null values, and then we can basically also input custom values to that, changing the null values to a specific value and so forth. All right, so another thing we can do is we can add a column. So just like you created your data frame or you created your Excel file, you imported it into Pandas, and for some reason you decided, you know what, I want to have another column that does something else. Pandas does allow you to add multiple columns. So in this example, say we want to add a new column. So here we're reading in a new data frame. This is called encounters_df. And then we basically check to see the first 5 records in the data frame. This is larger, so it took a little bit of time. Okay, so it returns the first 5 records in the data frame. So now, once we do that, we want to say, we want to see what the columns are. So we could either use the encounters_df.columns, it returns the total number of columns. We also want to check the data types of each column. We could do the encounters_df.dtypes. All right, so now what we want to do is, once we've gotten that, we can convert the string, because if you notice the date types are not of the correct format. So we can convert the string into a date type. And this is useful when we want to do computations with time. So here, what we're doing is we're converting the start date, because if we look at this, this has a start date, has an end date, has the patient ID, the organization, provider, payer, code for the, I guess, code for the type of encounter. So is it just a wellness visit or emergency visit and so forth. But here we have time info, and when we look at the what the data type for that is, it's a string as opposed to a data type. So we can convert that string, basically what we call casting. We can convert that string into the specific data type by rewriting that specific column. So encounters_df start column is equal to pd.to_datetime. So this function to_datetime is what converts a string into a specific date format. And because this is returned to the console, we have to save this in that variable by rewriting that specific column. So this converts the string date type to a specific date date type. And we do the same for the start date time as well. And you'll notice why we do this actually. The reason why we do this is we can just basically calculate the difference between the time, and we can do that, calculate it in days, in seconds, in minute, as opposed to, this will be difficult if we still have two of them in strings. So we have to convert them into date, and then we can just use the arithmetic operator, the subtraction arithmetic operator to calculate the difference. So we can do all kinds of fancy stuff with this. Here, what we're doing is we're creating a new column where we assign the difference between the dates of the new column, and also we convert that into number of days. So here we have encounter stop time minus encounter start time, and then we get the number of days that that patient stayed. So this is kind of like just a way of saying how many days did a patient stay in that hospital based on their start time and their stop time. And what we're doing is we're creating a new column to keep track of the number of days. So here we have, and this is the key here, this is us creating that new column. We call that column duration of stay. So you notice to create a new column, we don't necessarily need to do anything other than to just write the name of the new column in the data frame. So here we have encounters underscore DF, and then we have our new column that we're creating called the duration of stay. And then we assign that column to the difference between the start time or the start time minus the start time in days. So here we have .dt.days. What does this actually mean? This last one here. What that means is just basically telling us to get the number of days for the difference between the start time and the stop time, and create and store that into a new column called duration of stay. So basically, if we run this, let's run this real quick. It takes a little bit because, let me see, unsupported string. Okay, so we haven't done the conversion yet. I think I skipped a couple of things. Okay, so I'm gonna start here, 77. Okay, convert to start date. So we need to run this first, and then convert the start to date time. All right, so I guess we can run this now. Okay, so now when we view the data frame again, we run the data frame. You notice that now it does have let me see, does it show that? Okay, so what I'm gonna do is .info because I'm using a different mouse and I'm struggling with this mouse, so bear with me. .info. So you notice here we have a new column. It's called duration of stay. That column was initially not part of this. So this is the let me see, did we do an info here? If you look at this, this is truncated to the right. I'm trying to see if I could pull that. Okay, there we go. I'm making some progress with this mouse. For some reason, I can't pull the remaining values to the right. But the idea is with the initial encounters underscore DF, we did not have that column duration of stay. But now, because we were able to create that by getting the difference between the stop time and the start time, converting that to days, now we have that column. we can look at what that column looks like. We just segment only that column. Let's look at what that looks like. So we have that, and then we say, let's copy this so we don't make a mistake and type in, and we paste that there. So duration of stay, we just want to only see what that column looks like. So you notice most of them didn't stay up more than a day. So they stayed less than a day. So that's why we see the zeros there. If they had more than 1 day, you would see like a 1 or 2. But it seems most of the folks in this data set had a stay less than a day. So that's why we have the zeros. Okay, so this is nice and all to see that, okay, we see the zeros, but it doesn't really give us a description per se. One way we can basically get a very better description or summary of our data is by using the describe function. So the describe function is a way we can basically segment our data set such that we are able to get a better description of the data. So here it says, using the describe function on the entire data frame, we can get a summary of the distribution. So now we want to pass in the encounters df and call the describe function. So describe. What does that do? So with the describe function, it gives us summary statistics of our data frame. So it gives us the total number of count. For each column, it gives us summary statistics. This might be useful for this is in fact useful for our numerical columns and not as useful for the string columns. So you notice here, it gives us a sum of a total count of each column, gives us the standard deviation, gives us the mean, max, and so forth for each column. So we can get some kind of summary statistics of our what's it called? Our data frame using this functionality. So we can also use the describe function to get categorical values. So we can basically use that to get categorical values, count of the rows, unique count of the of categories, and so forth. Okay, so with our encounters, let's see what the categorical description is looking like. Let's see, value counts, tells us frequency, value count. All right, folks, give me 1 second. I'll be back. All right. I think there was a little bit of mix up in the materials. Okay. All right. So the describe function basically returns the summary statistics of the entire data frame. And we can basically use this also to return a kind of categorical description of our data frame. One of the ways we can do this is by using specifying the specific column that we want to look at and calling the describe function. So the column encounter class is a categorical column. As you can see over here, it has the, I guess, two categories. We have the ambulatory and the wellness. So the encounter class just talks about the type of visit. So is it an emergency visit where you're taken in by an ambulance, or is this a visit just for wellness? So here we can further describe that column. And you notice here, it gives us a count of the column, gives us the number of unique categories, I guess. And I'm guessing it's more than just two categories. From looking at this, you think it's two, but the description says here 6 categories, and also gives us the highest category in that column, which is the wellness column, and the total number of frequency for that category. You could also delve down into the summary or the frequency of that specific category by using the keyword or the function value counts. Value counts basically returns the frequency of each categorical value. So in this case, in the encounter class, we have the wellness category, we have the ambulatory category, we have the outpatient, urgent care, emergency, and the inpatient category. So this way you can build like really nice description of each of your columns if it's a categorical column, using either the value counts or the describe. So this only applies to categorical data, by the way. So you could specifically visualize a categorical column or give some kind of description of a categorical column using this. Okay, so now we want to start to filter our data. We've kind of looked at this earlier, so it's really nothing new to us, where we say we just only want to segment like a specific column. So here we're just looking at the patient column. We can specify that by using the code here, saying encounters underscore df and passing in the patient keyword. What does this do? It only returns the patient column. We could also do this with multiple columns. One thing you notice here is this does not return a data frame. In order for us to return a data frame, let me see, I think it's this one. In order for us to return a data frame, we need to do the following. I'm just going to copy this. We need to do pass in a list of values into the data frame. So this is a data frame, but what it returns there is just the textual values of the patient column. As opposed to what we saw earlier. You could also return multiple IDs. So in this case, we want to return the ID column. You can return multiple columns as well. You want to return the ID column and the patient column. So here we run this and it gives us just those two columns. You could also slice using index values. So, so in this case, we want to only get rows. We want to only get rows 2 to 5. So, looking at the data frame, we only want rows 2 to 5, or actually 2 to 4, because 5 is not inclusive. We can do that by using the index functionality. So so here we basically we have starting from index 2 to 4. So the way slicing works in Python, the start value is not inclusive, but the start is inclusive. So we'll see what that looks like in a sec. So it only returns 2, 3, and 4. It skips out on the 5th value. So that's just how Python works. The last index is not inclusive in the list of values. So here it returns row 2, row 3, and row 4, and skips out on row 5. Okay, I think here's a good place to stop for today. Just because we've covered a bunch of stuff, and I want to leave the last couple of minutes for any questions that you might have. We have about, I think, 9 minutes to go for today. So I'll pause here for today, and we'll pick back up from next week. If you have any questions, please feel free to ask at this point.
So,
Hello, sir.
Sorry, go ahead.
Sorry, go
Thank
ahead.
All right, thank you. Please, I tried to run the encounters for the patients to select the patients, but below.
Hello?
Below, yeah, I can.
Yeah,
I'm back.
Yeah.
Below selecting filters, yes, it wasn't running. The encounter.
Which one exactly?
Encounters DF wasn't running below understanding variables. Yeah, that side. So I had to.
Here?
Yes, please.
Okay.
I had to run it above it. I don't know why it happened.
So are you talking about here is not running, or which one? Oh, this
Yes.
one where I'm at right now?
Where you are
Okay. All right.
running, but when I run it above it, it runs.
Okay. So yeah. So the problem is this only applies to categorical values. So you can, if you do this and say describe, let me see. So we talked about describe, but for this, what were you actually running there? What were you trying to run? I think the best way for me to understand if I see your screen, because I'm having a hard time understanding what code you were trying to run there. But I will give you the solution to all of this in a later time. Yeah.
Thank you.
Yeah.
Yeah, thanks for the presentation today. So I have another question regarding the filtering. Looks like you can filter the rows using the numbers, right? Like 5, 2 to 5.
Right.
But can you do that for the columns as well? Or you have to specify the column name?
Oh, that's a great question. You have to specify the column names to filter them. Yeah, I don't think they're ordered per se. As far as I'm concerned, yeah. I don't think they have an index. Columns do. Yeah, I think the columns, they can be arranged as a list, but I don't think there's an index for the column. Say index 0 is for a column as, yeah.
So even with the one you show, the I lock, you show, so even that one we cannot use an index for the column?
For columns, I don't think so, but I might be wrong. I have to double check. I've never had to sort the column using index. I've never used the index before. Yes.
And if we choose multiple columns, that has to be as a list, right? That means has another bracket for
Yes.
the name of it.
Mhm,
Okay,
yes. Mhm. Yeah.
thank you.
Dr. Ebel, this is Jovita. I
Oh,
just want to let you know that when I try to use the value counts, right? And I think I added my code in the chat.
okay.
It doesn't let me do it. I get an error message.
Oh, okay. So when you do the value counts, let me see. So let me copy your code. Okay.
Yeah, and it's the encounters _df, and then in the
Oh,
bracket.
it's the way you write the value counts. That's why. It's value _counts. So I think that's what that might have been. Okay, let's run this. Yeah. Yeah, so yes, it's the so you have value dot counts. It should be value _counts.
Oh, I see. And the values _counts we only use for categorical
Yes.
value.
Yes. Yeah.
Thank you.
Okay, sir.
All right. Thank you
It's-
very much. Yeah. Do you have a question?
Yeah, it's not working. I realized it was reloading.
Sorry?
The question I asked about the ones that weren't working, I
Right.
think there was something behind, that's why. So it's not working.
Okay. Sounds good. Yeah.
Thank you.
Can you please show the multiple columns? Oh, I'm guessing you are referring to multiple columns in is it in selecting a data frame or?
No, it's right below this, the ID and patient, so encounters.
Oh, right. Okay.
That one, yeah,
Okay.
there.
Got it.
Thank you.
So this is just a way of like selecting multiple columns in your data frame. Say you just want to return just like specific columns as opposed to the entire data frame. You could just basically do this. And you could directly save this into another data frame as well. So data frame subset, and yeah. And then this value becomes a data frame subset. Yeah. Any other questions, comments? All right, if there are no questions, thank you all very much for today. I am available later today if you want to chat. Just you can shoot me an email. I will send your email. I just posted my email on the chat, so let me know. Available to talk about Python or data frame as well, or pandas as well. So thank you.
So again, thank you all for coming, and thank you, Dr. Nwafu, for an excellent presentation. I see in the chat room someone asking if you can be the professor for the rest of the series. So, Jovita, there are other excellent instructors as good as Ibel, so let's give them also a chance. All right, so we see you all tomorrow, same time for continuation of this.
Thank you.
Yeah.
All right, okay, bye-bye.
Bye.
Yeah, and don't forget, we do have office hours on Saturdays. I think Dr. Ebel has one.
Yeah, I have
today.
one today. Yeah. Yeah.
So and don't forget to subscribe to the TA channel. Okay, on Slack. Okay. Okay. Thanks.
Bye, y'all.